Welcome to day 4 of the Inventor.io 30 Days Lost in Space adventure. In yesterday's adventure, we wired in a dip switch and we wrote logic to communicate with the inputs and outputs of the board from a constant 5-volt supply to enable this LED in a couple of different ways. The way that they had us do it in the exercise was to just have the light turn on solid. And the way that I did it as my own personal touch was I made it blink. This lesson is a little bit more of the same, where it's utilizing more of the dip switches. So we're going to wire in a couple of more lights in the circuit and write the code for the additional switches to do what they're going to do. So let me watch the video, and then we will go to the computer and go over the sample code, and then we can play around a little bit and see what we can do with the additional lights that we put into our breadboard. So let me switch to the computer and I will see you there. Okay, so I made my way through most of the video. The premise is pretty much the same. It's just additional circuitry wiring in 3 lights instead of just the 1. They're using the common positive rail on the breadboard to feed the 3 switches on the 3-position dip switch, and that goes out to the grounded input wires here. So there's an input on pin 2, 3, and 4. Each of those has a ground via resistor. There's 3 outputs coming from 10, 11, and 12. The outputs go to the resistors to supply power to the 3 LEDs, red, yellow, and green. 3 ground wires, and the ground wires tie into the common ground terminal here, and it returns to the ground point on the Arduino board. The code is very much similar. So I'll take the code that I have and I'll just change some of the stuff. I'll say switch 1 is 2, switch 2, switch 2 is equal to 3, switch 3 is equal to 4, and then I will say, yeah, I'll stick with red LED is 8, yellow LED is 9, and green LED is 10. I can copy the pin mode sections. So I can copy this input, make 2 copies of it here, and just say switch 2, switch 3. The red LED for the output, I'll copy those, and we'll say red, yellow, and green. I'll take my section of if code, copy that, and let's dumb it down a little bit before I do that. I'll get rid of the delays just to go based on what they're showing in the example. Copy that. Paste it. And now that we're building a larger program, we could and should start using comment sections. So we could say switch 1 red LED, comment here, switch to yellow LED. And switch 3 green LED. We'll change these guys here. I'll compile, see if there's any error messages. There were no error messages, so that means that everything should be okay. I did notice here that I didn't switch these guys, so I'll change these to switch 2, switch 3, or else we will have an erroneous operation and all 3 of our lights will turn on with just the one switch. So that looks okay. So what I'll do is I'm going to switch back to the overhead. We'll do it a little bit differently today. I'm going to wire up the board from bare bones just to get some practice on that portion of it. It may take a little while longer than I think it will, but if it does, I'll just fix that in post. So I'll be right back. Alright, so we're back to the overhead view. You'll notice I've taken everything apart. I want to start fresh and see how well I can do this without any assistance from the diagrams or anything like that. If it does take too long, I will speed up that portion of the video. But now I'm going to try and assemble everything here to get the red, yellow, and green LEDs to work with my board. I'll double check the schematic after I'm done to make sure I don't burn anything up, but for the most part I'm just going to work my way through here. So for starters, I know that I want to have a common ground point. So my common ground point will go to the ground pin on the board and the ground pin on the breadboard. I've got my 3-position switch that I will put it over here this time. I've got my 3 LEDs, so I'll do red, yellow, and green. And again, pay attention to how the LEDs plug in. The long leg is the positive side, so you'll always want to make a reference of which side you put your positive lead on. In my case, I double checked that the long leg goes to the right, but it can go to either one as long as you have the positive power going to the right position. The 5-volt continuous, I'll plug into this side on the positive leg of this terminal rail. I don't have a lot of red wires, so I'm going to have to kind of wing it when it comes to that. But here I'll just tie in this power to this point, this power to this point, and this power to this point. From there I know I have to come out from here, and then I have to plug into the inputs. So there's actually 2 5-volt points, so I'll use the second 5-volt point because the wire doesn't like to reach over to the furthest one, so I'll use the one in the middle. So now I need, these are my outputs. I want these to be my inputs. So 2, 3, and 4. Almost out of boo-boo. So power to here to switch, power goes to input, and then from there we tie these outputs. So I need a couple more wires. trying to do this without leaning forward and getting my head in the shot. Alright, so looking back at my code, I want my red LED to be output pin number 8. So red LED, positive side will go to number 10. Yellow will go to 14. Blue will go to 18. And then we connect our resistors. Okay. That looks pretty good so far. I have to get 3 more grounds. Tie those into my ground rail. And it looks like I need 3 more resistors, doesn't it? So I'll move these up to these 3 positions here. So I can have some close quarters for my ground points. And generally speaking, good practice would be to trim the legs coming out of these resistors. So I'm not really practicing good measures here. And the last one. Okay. So it looks like we're in good shape here. I'll double check the schematic because I made that boo-boo earlier. So we got power coming in to the 3 points on the switch. Those 3 come out with resistors to each input, and then each output has its own LED connected by resistor. I think we're in good shape. Alright, so moment of truth. I will plug in the hero board. It's still running the same routine as it was running earlier with the flashing red light. And now I will upload my new code. From the looks of it, the red light is on solid. I have a pencil that I can use to flip the switches. Yellow goes on. Green did not. Oh, I see why green did not. I do not see why green did not. Oh, I have it in the wrong point. Okay. No, it's there. You know what it is? Green is really dim. So it's on. I just didn't notice it. Turn it off. Turn it off. Turn it off. Yeah, green's not a happy guy. Let's try something. Let's try flipping this green LED out in favor of one of these bright white LEDs. Make sure I get my pins right. There we go. That works. So test it out. So now they're all working. Try a different green one, see if it makes a difference. No, the green ones just aren't as bright. The green ones aren't as bright as the other two. I could turn off the lights in the room. Maybe you see that a little bit better. And now what I can do to play a little bit is let me switch back to the computer view, and we're going to play around with this code a little bit and see what kind of trouble we can get ourselves into. Okay, I'm back. So what I did was I changed around the logic of each of the switches. So if I'm using switch number 1, red, yellow, and green will all light up. If I'm using switch number 2, red, yellow, and green will flash at a delay time of 200 milliseconds. And if I turn on switch 3, red, yellow, and green will flash in a sequence. So it'll be red, yellow, green, red, yellow, green, red, yellow, green. Not quite exactly what they were looking for, and I'm sure that there's a better way to do it than to continue building all of these digital write statements, but this is where we're at so far, so this is what I'm kind of comfortable with. So I'll go back to the overhead view and I'll let you guys see what I've got with the code that I just made. Okay, so here I have the layout. None of the wiring changed. All I changed was the code. So I have it set up now to where the first switch will light up all 3 LEDs at once. The second switch will flash them at once. And the third switch will flicker them in series. So I'm pretty happy with the progress so far. I think the slow and steady pace is pretty good, and from what I've been picking up from all of the back and forth that I've been doing and messing around with this and just playing around with what we have here, I think I'm learning a little bit as I go along. I think it's a pretty good kit that they've got going here so far. That pretty much sums up my 4th day. I'm pretty happy with where I've gotten so far. So full disclosure, as of today, I am now enrolled in the Inventor.io affiliate program. So I will post affiliate links in the description to order the 30-day Lost in Space kit as well as the other kits from Inventor.io. And ordering through those links will just help support this channel. I have been putting a little bit of time into making these videos. The support would be really appreciated. So that pretty much wraps up day 4 for me. I think I'm making a lot of good progress. Don't think that the affiliate link is going to do anything to steer my opinion of the Inventor kit. I do think that it's a great kit to get started in the world of electronics. I, again, saw this in a Facebook ad, and had I not seen that Facebook ad for Radio Shack selling these kits, I would not even know about it, nor would I have even given it any thought to try this out. And since I've tried it out, I've made contact with Austin from Inventor Kits, and he steered me in the direction of the affiliate program, as well as a potential to sign up to be part of the beta program to test out new kits that will come out in the future prior to their release. So anyway, that concludes my day. Please be sure to like and subscribe if you enjoy the content. Thank you to my patron Craig. Your contribution is greatly appreciated. Anybody else, if you wish to support the channel, either via Amazon affiliate link, inventor.io affiliate link, or Patreon, please feel free to do so. So stay tuned for day 5 of the inventor.io 30-day Lost in Space adventure, and we will see you then.